Alright, so finally the last example here for section 1. Here we're going to be finding both angular and linear speed. So we're talking about a circular saw blade. Rotates at 2400 revolutions per minute. So if you think about that, 2400 revolutions per minute, that's quite a bit. We want to find the angular speed of the blade in radians per second. So if we want to find the angular speed, remember angular speed is just theta divided by time. Well, here's the only problem though. 2400 revolutions. So if we want to write out 2400 revolutions, all right, that's what the information that's given to us. So revolutions per minute. So that's over 1 minute. Well, you're going to have to convert this revolutions into radians. So if you think about it, right, isn't theta in radians? So if it's in radians, what you need to do is you need to say, well, I know that 1 revolution around my circle is equal to a 2 pi radians. Well, at least some of you know this. I know it. And then what we want to do is we are trying to find in radians per second. So we are in minutes. So what we need to do is we need to convert minutes into seconds. So 1 minute is equivalent to 60 seconds. So what you do is you multiply all this through, and what we're going to do is we're going to leave our answer in this answer, angular speed, we're going to leave in radians. So in terms of pi, really I don't care if you leave it in terms of pi or if you turn it into decimal, but in this case we're going to leave it in terms of pi. That ends up and gives you an angular speed of 80 pi radians per second, because your minutes are going to cancel. So radians per second. And then that's what's going to be your answer here. So, alright, so that's for part A. So that's finding your angular speed. Now remember we talked about how you can find your linear speed. Your linear speed is just your S over T, which is the same as S is equal to an R theta over T. Or we can say R times theta over T. Well, let's see. Theta over T. I feel like I figured that out before. Yes, for those of you that remembered, you're going to be taking your radius times your angular speed. And the sweet thing is we already figured out our angular speed in part A. So if we find out what our linear speed is, we're going to take our radius, which is 4 inches, and we're going to multiply that by our 80 pi radians per second. Remember, per means you have a fraction. So if we have 4 inches times 80 pi radians per second, this is over 1, that will give us approximately, this answer will actually write out as a full answer, 1,005 inches per second. So those of you that have played with a saw, because everybody always likes to play with the saws, cut up anything ever you want to. Sometimes I like to find dead mice out in the yard and maybe throw them to the circular saw, just see what happens. Oh, don't look at me like that. They were already dead. I poisoned them. But anyway, what happens is that blade travels 1,005 inches per second. So if you want to convert that into feet, that's like 2 feet per second. Okay, maybe a little more. But that's a lot. So that is your linear speed of, if you have your saw, that is this point right here rotating around 105 inches per second. That's kind of fast. So I hope you guys enjoyed your 4-1 notes. And if you have questions, because I know you will, don't hesitate to ask. Just don't ask anybody that used to take this class, because more likely they've probably forgotten. just don't forget, I'm back.